Hi there, folks. In this video, we're going to talk a little bit about and just get a brief introduction on exponential growth and decay. Now, we've previously learned that in a geometric sequence, this would be the explicit rule. A sub n equals a sub 1 times r to the n minus 1, where r is the common ratio. However, it does make sense sometimes to talk about a sub 0, or how much do you have to start. Okay? So it's not necessarily after the first application of whatever the growth or loss is. So, when that happens, we have this different rule. Okay? And it's a sub n equals a sub 0 times r to the n, where a sub 0 is the starting amount, r is the common ratio or the rate of change, okay, also known as the growth or decay rate, and a sub n is the final amount. So, you're welcome to pause this and get a chance to write that stuff down. However, we are a little bit cramped for time, and I don't want to keep the YouTube video here waiting, so let's just get started. Okay. In our first example, it says, you have found a nest of infant ocelots. After researching on the internet, you know that the animals lose their infant coat at a rate of about half their coat per month. If their infant fur has a mass of 1,850 grams, how much infant fur is left when the ocelot reaches 11 months of age? Now, if you research this, you're going to note that I totally made up this 1,850 number. But it fits for what we're looking for. Now, what we're looking for is how much fur is left at 11 months of age. So, what we're actually looking for is a sub 11. Now, we know that the ocelot started off with 1,850 grams of infant fur. Let's just go with it. And we note that they're losing half their coat per month. Okay? Now, that's equivalent to a problem where, you have bacteria that's growing or an isotope that's decaying at half the mass per month or per year or whatever it may be. But we want to know after 11 months. So, okay, I have a sub 11, because it's 11 months, equals 1850 times 1/2 to the 11th power. So, I get out my trusty calculator, okay, and I'm just going to type it in. All I'm looking for is for you to show me the formula, okay, with the numbers in it, and then the calculator can do everything else for us. I do not expect you to do this by hand. So it says at the end of 11 months, it's only going to have about 0.90 grams of infant fur left. Okay, or 0.9, depending on your perspective. But if we go to 2 decimal places, it's 0.90. Okay, so that's our first application of the problem. Now, in another problem, this one applies when we have money involved. And we kind of dealt with one of these earlier. Okay? It says, you have a super rare Darth Vader action figure with double telescoping lightsaber that was only available as part of a pre-sale set in 1977. Your parents paid $2 for the individual figure back in '77. Collectors have found that this figure, when it's professionally graded in mint condition, has increased in value by about 25% each year. What was the value in 2010? Okay, so what we have to do is, first of all, we need to figure out after how many years are we looking at? So, if 1977 is year 0, okay, that makes 2010, okay, and all we got, in order to figure this out, we just got to subtract. So that makes 2010 year 33. Okay, so that's the first thing. We have to find out how long. Now, we can plug this into our formula. Okay, so A sub 33, because that's what we needed to find, equals the value of that action figure at the time, $2. Now, it's increasing by 25%, so we need a way to incorporate that into our value. So, when this happens, okay, whenever something's growing and they give us a percent, it's always 1 plus that percent. Okay? So, as a decimal, that 25% is 0.25. And then, in this case, to the 33rd power. So we're still using that same formula. Now, I'm just going to type this into my calculator. Now, you are welcome to rewrite this. It matters not to me. So, I get out my handy-dandy calculator again. 2 parentheses 1 plus 0.25 to the 33rd power. And it says that action figure in 2010 was worth $3,155.44. Now that's because that item appreciated. Okay, so if it appreciates, okay, it goes up. Okay, if it depreciates, that means it goes down. Okay? So, as a variation on this, since that's an increase, okay, that formula was used exactly as you saw it. Had that been a decrease, that would have been a minus sign. Okay? So, for depreciation, okay, it's A sub 0, what you start with, times 1 minus the percentage rate, okay, which we don't know what that is, to the n. Okay. And that is all for this evening. Okay, so have a great day.